Yeah, so hello everybody, and welcome. We are going to start pretty much soon, and how do I say? We are going to have a live stream of the Progress MS-31 cargo resupply spacecraft that will be undocking from the ISS, from the International Space Station. So we'll be going in. So yeah, let's go. Okay. Hello everybody, and good evening. I'm Daniel Suguwa. Okay, okay. So I've okay, already closed unimportant loop there. So let me say this once again. So hello everybody, and good evening. From me here in Sarawak in Borneo. It's around 9:17:22 p.m. right now here, and on 16 March 2026. So hello everybody. This is I'm Dylan Sugwa, your host today for this live stream. So today it is 75th live stream of myself here, and we are going to see the undocking and also departure of the Progress MS-31 cargo resupply spacecraft from Roscosmos. We are going to see that soon, as the mission is already closing in, and also, of course, it's going to departure pretty much soon. Oh, and looks like we have live from. Oh yeah, if you can hear it. Yeah, so apparently we have live from the Roscosmos. It's already start right now, so why not we just go ahead with the stream? Um, okay, so looks like we have a signal here. Okay, not much else we can say. Okay, so I think, yeah, okay. So there's not much else we can talk about, but I'll give you a little bit overview about the Progress MS-31. Let me show you here. Mhm. Okay, Progress MS-31. So this Progress MS-31 was launched on 3 July 2025, around here, 7:32 p.m. UTC, the Universal Time Coordinated. So, and after that, it 2 days later, it docked to the Poisk Zenith module on 5 July 2025 at 7 sorry, at 9:27 p.m. UTC. So that's that, and it does bring some pressurized and also unpressurized cargo to this space station. Of course, it really carries, as usual, best consumables, aka the most basic thing in life, such as food, water, and there's also air, of course, because in space there's literally hard to try find that. So that's the pressurized section, along with the equipment, for, let's say, for example, for the maintenance and also for the scientific research. There is like a payload on board and whatnot. For the unpressurized side, the section, it contains tanks of fuels, water, and also gases that will be that are transferred to the station, to the automated system. Some of the line there, in case you're wondering, that's why. And yeah, for that mission, it actually carried around 2.625 metric tons, around 5,787 pounds if you're using imperial system, which, just like here, the cargo and supplies. Um, okay, so never mind, but it's fine. Why? why not we are talking a little bit on the pressurized supplies. It carries around at the time 1,205 kilograms, aka around 2,657 pounds if you're using imperial system. Okay, now we're switching again from metric tons to thousands of kilograms, but it's okay. Okay, and for the fuel, it carries around 950 kilograms or around 2,090 pounds for imperial system. For water, it carries, you guess it, nice number, 420 kilograms, or around 930 pounds for you guys still using imperial system. And for the nitrogen gas, okay, um us using metric here, it's 50 kilograms, or for you guys still using imperial system, it's 110 pounds. So yeah, that's that. We have already seen it, and of course it was launched on the Baikonur Cosmodrome on the site 31/6, onboarding the Soyuz 2.1 A rockets. So that's that. Here, as you can see, this is it. And why not I just show you guys here? And apparently we have a little bit of ambient music here. Okay, there's not so much else interesting, but I'll switch to desktop audio. Okay, and how do I say it? For this mission, it will be undocking to from the International Space Station. This one, specifically the Progress MS-31. Yeah, and in case you want to know, Progress spacecraft were actually some sort of like derivative of Soyuz. So these two are linked together, and sometimes because it link and it doesn't have too much difference. So that's why I'm using. That's why if you see on my thumbnail here, yeah, if you see, actually on the right side, that's actually for the Soyuz, Soyuz MS spacecraft. But however, because the similarity between these two, between the Progress MS and also Soyuz MS actually stands for modernized system, if I remember correctly. Okay, because the difference are not that big, so I just use the thumbnail for the from derived from my previous stream, if I remember, around Soyuz MS-26. Yeah, it's been a while. Well, isn't it? It's like around a year ago, almost a year ago, from what I remember, around April. Yeah, so April 2025. So it's quite a time. And yes, as you can see, there's not much else super duper interesting thing we can see. Yeah, unfortunately, but yeah, I can say in terms of coverage and the way how they actually conduct this one, it's certainly not the best. Yeah, not much compared to, let's say, from JAXA, ESA, NASA. Yeah, so it's a bit boring. And we have undocking. Undocking procedure has already been started around, okay, slightly more earlier than what I thought, because in my local time they should have already been undocking around 9:26, but apparently or 9:25, 24, I don't know, but it looks like nominal undocking. And at this moment, around this nominal undocking, usually what will happen, what will actually happen around this time, is that it will slowly it will actually just slowly departing from the International Space Station, the ISS, of course, because it has to respect with the how do I say the safety bubble. It has to adhere to that imaginary safety bubble there, especially even if it's not for approach, it will do the reverse. It still has to use that procedure around first 100 and also 200 meters. It will go around that small epsiloid, small imaginary epsilon bubble safety there, and then followed by the wider one, the 1 kilometers wide there. actually a little bit bigger if I remember correctly, around 2 kilometers by 2 kilometers or something around 4 kilometers at the maximum extent. Yeah, so at the maximum extent, it would have been like that. Okay, looks like the internet connection does not 100% cooperate, but it's okay. I don't think we should actually worry too much. And as you can see from this procedure, usually what actually happens is that as it actually slowly descend out from the International Space Station, of course, even before it's departing from the International Space Station itself, it has to check some sort of like a kind of system here and there. Sometimes it does need to check something. For example, maybe it needs to check in terms of IMU, the inertial measurement unit. It has to check that, and it has to see whether or not everything is good. Oh, yeah. Oh, yeah. Okay. Now we are synced into live. That's why I intentionally just clicked that. But however, you can see the view of the bottom. I believe should be at the bottom of the International Space Station. You can see it looks pretty nice, especially if you even look at that at this one. This is actually uh, if I remember correctly, for this one is from the television signal from the TV telemetry system from the Soyuz itself. So at least on this kind of part, it has some sort of like the analog system here. As you can see, why? Because you can see uh, it doesn't looks pretty sharp there, and it's something I can say if you use CRT, probably you will appreciate it. But of course, even though despite the analog signal of the despite the analog look of the TV itself, the telemetry system usually it uses a much more digital system here and there. So you can see, personally myself as an enjoyer of both analog and also digital system, it's actually looks pretty nice there. But I have more fun with analog TV system here. Yeah, so that's why it looks like some recording from the VHS tape system there. So it looks pretty nice. Okay, and even though it's mostly pretty much an ambient music here and there, but it should not have been too much of problem, and it's looking pretty fine. Okay, and as you can see, as it slowly departs, I believe this should be around 200 meters or maybe 300, 400, 500 meters. We shall see. As you can see on the telemetry side here, it does show what kind of figures, but from what I can tell, it doesn't tell us how many meters here, but we can guesstimate a little bit. This could be around 500 meters here. So by this point, it should have already safe out from that small centered epsilon bubble there. Okay, and then what's next is that it will be a 1 kilometer, um, 1 kilometers imaginary bubble safety there. Once it's already out there, then the mission will finally proceed and go for re-entry of the Progress MS-31 spacecraft. Okay, and for your information, usually when this spacecraft actually re-enters back to Earth, it will deliberately re-enters back in around the Pacific Ocean, around the Point Nemo. Point Nemo is basically around the point where there is no island, there is no land, no people, no civilization whatsoever. It's basically a vast empty of ocean. So usually when it re-enters, it should possess little to no problem uh, to the to the surrounding, and should not be too much problematic to the wildlife. Hopefully, as the debris sometimes can be a little bit tricky there. Oh, maybe I should just open.
Экипаж МКС Москвы в канале ЗГ-1 для...
Okay, let me try open. Okay, so we are going live here. We are using something else. Sorry everybody if you see interruption. I've already changed it to something a little bit safer. Okay, and as you can see, this the at least from the time and the stream itself, it has a slight delay, but it's not a big problem, fortunately. And fortunately, this is not a very intense stream, so okay. So
Сереж, даем добро на перевод КВД. Ми-2 положение закрыто.
okay, so from the telemetry call out there, you're actually hearing from the color left mission control, if I remember correctly. This one actually located around Moscow, Russia, as they are communicating together about the about the coordination of the departure of the undocking and also departure of the Progress MS-31 spacecraft. That's one of the rare thing you heard so far about this telemetry one, but it should be pretty interesting. Okay, okay, so that's another call out we hear from the core left mission control. Okay. I mean, there's not so much else interesting here, but if you are, for whatever reason, decided to joining in to the stream, hello, and welcome. You're an awesome people out there. Decided to just go and watch this anyways. Yeah, so thank you if you're actually joining in. Even though from what I can tell from current viewers right now, no one actually watching here. And I believe this should be the view from the International Space Station, or could be a pre-recorded video. Okay, because it's weird. They suddenly change into this one. But however, as you can see, at that point it should have already going out from the imaginary bubble safety zone around 1 kilometers wide. Sometimes it can go slightly a little bit stretch around 2, 3, 4 kilometers. But by now, I believe that the checks about IMU system, the inertial measurement unit system that actually controls the guidance of the spacecraft, and also system inside it, electrical system, electronical system, telemetry side, and also the signal should be good. And this is the look right now. Looks like there's a little bit of loss of signal, as you can see, because the time there, it's not moving. Yeah, because usually there should be one. Okay. Okay, so that's it. That's all from the live stream here. Nothing else too interesting. Okay, so that's it. There's nothing else. It's already finished. Yeah, it's pretty uneventful. Fortunately or unfortunately, it's pretty uneventful. But yeah, I can say because um, how do I say, my channel is sort of a little bit of boutique niche channel, just to say here, because how do I say, if you actually look around. Oh, what's it? Okay, so what's even the call there? Looks like there is still telemetry call. Okay, so that's it. It's already finished. Nothing else to watch here. But if you actually watch it, watch this stream, you're awesome. Because well, at least we can talk something here and there, even though there's no viewers for now, other than probably early viewers. But thank you, thank you. If you decided to watch this on how do I say, if you decided to watch this on replay, also thank you so much. Yeah, and how do I say, before we actually end the stream, and also because I need to go to sleep, I need to have a good rest for tonight. So how about I'm going to show you some of the interesting spaceflight event around. Let me see here, and yeah. So guys, let me let me actually uh find here. Okay, give me a little bit of second here. Yeah, for whatever reason, I'm using the plug-in YT tweaks, and whenever I'm using video focus, I cannot search anything else. So that's a little bit of sad, but it's okay. We can go. How do I say? Yeah, I would like to show you this one because yeah, I forgot to mention that there's also a launch, another recent launch of the Electron rocket by Rocket Lab. That one, even though the missions are pretty much quote unquote kind of secretive, but so just like how do I say, previously, as as we've already suspect, it could be the launch of the Black Sky. Oh, looks like it's actually a Black Sky Global 34. So yeah, I don't know why they decided to just not announce it. And you want to know what's something funny? They actually announced the flight mission here pretty late. You know, it's like around 1-2 hours before that. Just like previously, they announced it last minute. So obviously, I don't have any time to properly prepare, and I'm still pretty drowsy anyways. Around that morning, you imagine, I'm not even expecting it's going to go live. So well, but I did actually catch the stream at the time, so I'm going to show you here. I'm going to show you the launch replay. This one actually around 10 days ago. Okay, on 6 March 2026. The mission, how do I say, the mission title name is Inside at Speed. It's a friend indeed. So that's it. Let me. Oh, so let me try go with the last 32 seconds like that. I'm going to show you guys the launch replay. So let's go in. So this one, a launch of the Black Sky Global 34. So in case you want to know, it's basically it's an essentially an Earth observation satellite, and I presume the reason why they actually make this kind of secretive is that possibly because of, I don't know, I believe because the classified nature of the payload, even though weirdly enough, around a few earlier flight of these, how do I say, black sky Earth observation satellite, it's not around that kind of super secretive back then. But I don't know, that's, well, if the payload is, if they decided to just make it too secretive, well, what else can we do? Black Sky Global 34, sorry, 32. Is it correct? I need to look. Yeah, okay, so this is correct. I need to double check my information. Okay, so oops, sorry. Okay, so I believe here I should be putting out. Okay, I think we can add a little bit here. Okay, should be fine. Yeah, should be fine. So I'm going to show you the launch replay of this one. So let's go and let's watch of this launch replay 10 days ago. So let's go. Oh, all right. Okay, so this is the launch. We're going to see full launch, full replay launch of this one before
T-minus 20 seconds and counting.
before I'm going for the sleep. Okay, T-minus 15 seconds, 14, 13, 12, 11, 10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5,
4,
4,
3,
3,
2,
2,
1,
1.
ignition, and then lift off 10 days ago from the Mahia Peninsula. This one from the Pet 1A. Okay, as you can see, the Electron rocket lifted off carrying the Black Sky Global 34. Even though they never announced this properly, but based on the deduction of the how do I say, the stage dropping rocket stage drop zone, they the NASA spaceflight communities basically decided to just basically able to trace out that this could be a Black Sky Global 34. So yeah, and as you can see, this is the zoom view. And this is the long-range optical camera view, or that we are looking at the rocket itself. And after that, we shall see.
Max Q.
Okay, before that it's supersonic, and after that it's max Q. Should be hearing max Q here around this replay.
Cleared Max Q.
Okay, and afterward it's already cleared the max Q.
And there goes the call for Max Q.
And
Electron is performing nominally
how do I
during
say?
this
I need
first
to tell
stage
you that
burn. We're now
before
hitting
it
speeds
reaches
of more than
even
22,000
the
kilometers an
supersonic,
hour at more than 20
the
kilometers
rocket
above
engine on the
Earth.
first stage,
Now, our
specifically
next
the
milestone
9
coming up will be
Rutherford
those
rocket
staging
engines
events we
were
talked
throttled
about
down
earlier.
back to
The first one is called
60%, or
MECO,
could
or
be
main engine
a
cutoff,
little bit
when those Rutherford engines at the
or
bottom of
could
the
be a
rocket
little bit
power down
a
completely.
little bit
Once that
lower than
happens,
that.
the
Could be
first and the second
40%,
stages
could be
separate
30,
within a
20,
few
but
seconds of
usually
MECO.
not too
Then,
much.
after
It
that
should be around
separation,
40
the
at
Rutherford
maximum.
engine on the second stage will
Okay,
ignite.
and that one is
So
actually to
that's
reduce the
MECO
mechanical
stage separation, and then
peak stress
second stage engine startup coming up
incur
very shortly at
on
around
the
T
rocket
plus
itself,
2
and
minutes
also to
40
keep the
seconds.
payload inside there safe from excessive vibration, and
Stage
also
1 propulsion holding nominal.
mechanical
Stand by for MECO in
stress
roughly 30
problem,
seconds.
of course, because without it there's going to be a lot of problem, and this satellite itself could have been damaged, and also even the how do I say, the NOSCON fairing there, it could have collapsed
15
if it's
seconds to
going
staging.
too fast.
Entered burnout
I
detect
mean,
mode.
I mean the the easiest way for you to know about this one, just look at the Long March 2E rocket launches. What happened when the NOSCON fairing literally
MECO
collapsed?
confirmed.
On the worst case scenario, it literally just ended the mission, explode.
Stage
On
2
the
mission confirmed. Stage 2
okay,
separation.
and after that you see there is MECO, main engine cut off, and afterward stage separation
Beautiful
and
work
the
by
ignition
Electron there.
of the
We are clear through
second
MECO
stage.
and
This one
stage
is the
separation. And there
vacuum
on your
Rutherford
screen is the glow
engine
of the
on the
second
one there.
stage Rutherford engine as it continues
Okay.
the mission on to its
And
470
how do I say? Let
kilometer
me
orbital
continue
target.
what I'm going
We're
to
now
say.
at T plus
At
3 minutes into flight,
at the
traveling at
worst
speeds
case
of more than
scenario,
80,000
the Long
kilometers
March
an
2E,
hour.
if I remember,
Up
carrying the
next
F
is
star
fairing
2
jettison.
or
That's
3,
when
if I
Electron's
remember
nose cone
correctly,
separates and falls away.
the NOSCON
Keep an eye
fairing
on the
literally
screen. We
collapsed due
should
to
hopefully see those
the
two
sheer
fairing
amount
halves
of
fall past our engine camera.
due to the high upper wind shear shear speed, and then after that,
Fairing
sorry,
jettison confirmed.
and then you can see there's a fairing jettison confirmed around
There
T
they
plus
go, and that
3
was the
minutes and
call-out we were
around
expecting.
37
Fairing
minutes,
separation confirmed by
3 minutes
mission
and
control.
37 seconds into
Now
the
we're
flight.
counting to
You
hear,
can see
we're counting
separation
down
of
to hear
the electron
nominal
rockets,
call-outs from the team and the mission
electron rockets,
continues. All
nose
is on
confirming
track for
there,
our next milestone,
which
will
actually
be the battery
exposes
hot
the
swap on the
Black
second
Sky
stage
Global
to
34
continue
satellites into
powering
the
that
space
Rutherford
environment.
engine. That maneuver
And yeah,
is
let
expected
me
to
continue
take
again.
place at around
In the worst case
T
scenario,
plus 6
about
minutes, 40
if
seconds into flight. So we've got a
if
bit
the
of time left for those current battery packs to continue
yeah
doing their thing.
if the NOS if the rocket actually goes way too fast, or let's say if there's like upper wind level there, it's way too speedy, it can cause the NOSCOM fairing to actually collapse. In the least worst case scenario, the usually what will happen is that it literally it pancakes the satellite, and literally even though it's actually able to go to the low Earth orbit,
Stable
it's
propulsion
it's
holding
best
nominal.
it's effectively
The
not
next major
really
milestone
useful.
we're expecting to see will be
Okay,
battery
but in the
hot
worst case
swap.
scenario,
Since
on
Electron's
the
second
Star
stage
2
flight
flight,
time
if I
lasts
remember
longer than the
correctly,
capacity of the first set of batteries,
2 or
the
3,
rocket's flight computer will make the automatic switch
the
to a
rockets
fresh new
literally
set when it's time.
literally
Once the
explode
hot
after
swap
that,
has
killing
happened,
killing
Electron will
around 6
jettison the
7
old dead
around
battery
6
packs
or
that it no
7
longer
villages
needs. You'll be able
nearby
to see those disconnect in
when
real time.
actually
They're
being
the
hit by the
shiny
debris.
silver
So
packs on
that's
your
why
screen there.
the rockets there,
The jettison happens
it needs
quickly, so
to
if you blink and you miss it, we should get a call out
so
from
that's
mission
why
control at the
that's why
same
the
time
long
to
march
confirm that
sorry
action took
so that's
place.
why rockets usually it has to go slow down before even before it reaches supersonic, and also after, and also even before max q it needs to slow down. So that's why. And yeah, and you can see here's the flight itself, around T plus 5 minutes and 45 seconds. It looks nominal here, with the
Guidance is nominal,
velocity of
200 seconds remaining.
12,600 kilometers per hour and altitude 103 kilometers, and counting from this flight, as you can see on the replay itself here. And then afterward, we are going to see here.
AGB
Sorry.
discharge holding nominal. Approaching
af-
hot swap in roughly 30 seconds.
Yeah, after that there is battery hot swap there. Basically, what it does is that the another second pair of the battery that's basically on the cold state, it
Throttling
usually
down.
will be going open up again, and then this already depleted battery will be these two usable disposable, no longer useful battery anymore due to the discharge.
Jettison
And afterward,
confirmed.
you can see there's
swap
battery jettison there. That's how it does.
And there they go. Battery hot swap is successful, and Electron's second stage engine is running on a fresh set of batteries. This new battery system will power the second stage all the way through to the end of its flight time, which will conclude with the shutdown of its engine and separation of the kick stage with the mission's payload. Now, still a couple more minutes of engine burn time to go. Otherwise, all looks nominal for Rutherford and the second stage. We're moving now
Yeah,
at
so
more
here we
than
go.
almost 18,000 kilometers an hour and around 193 kilometers above Earth.
Okay, so I'm testing out. Okay, so in case you also
FTS
want to
as
know,
saved.
is that what happened. What also
At T plus
as you can
7
see, the
minutes
reason
and
why
40 seconds
why
into
the battery
flight, everything is
jettison has to be
proceeding
done is
nominally
that
for this
because
mission.
most of the
Operators in
rocket
rocket
engines
engines continue
here,
to monitor the vehicle
unlike
systems closely as
unlike
we approach
most
second
of the
stage
rocket
cutoff
engines that
and
we
kick
know,
stage
it uses,
separation
like, for
for the
example,
next
gas
phase of the
generator,
mission. We're
type
just a
of
few minutes away from
cycle,
this milestone, and the second
or
stage
even a
is
full
accelerating
combustion
well,
cycle.
getting closer
This
to
one,
the speed we
this
need
one
to
does
enter
not
orbit
use
at
any
around
of that. It doesn't use the
27,000
turbo pump.
kilometers
It
per hour.
instead replaces those turbo pump with the battery and also the DC motor. And of course, you know that with the current technology, the battery itself, it has not really the best kind of energy
Right, we're coming
density.
up on the
So
final actions
of
for
course, that's
Electron's
why
second stage
they
now,
have to
with
carry more
Seco
battery.
just a few seconds
And even
away
though
before
it
we
actually
separate the
goes
kick stage
with the
this
cost
mission
of
satellite.
the
What we're expecting to happen next is that we'll
of
see
slight
the engine's
reduction
red-hot nozzle start to cool
of the
with
mass
engine
and also
shutdown,
the weight
and
of the
that will be
satellite
our
that it can
visual
carry.
confirmation that
But
SECO
the
took
good news
place
is
with
that
no
it's
issues.
much more
Alongside
simpler
the audio
and
call-out,
much
we can
more
expect from Mission
much more
Control
easier
at
try
the
to
same time. Now let's
develop
listen
a
in for
rocket
that
engine
call-out
in
signaling
comparison
we've
to
cleared
say
SECO and
using this
achieved
turbo
kick
pump
stage
based
separation.
rocket engine for the liquid field rocket stuff. So that's why. That's why. And afterward, there is kicks, there is Seco here, second engine cut off, and then followed by the stage separation, and then the kick stage
Trigger
separation, which the Curie upper stage rocket engine
Nominal
carries out
transfer orbit achieved.
to the correct
Stage
orbits.
separation confirmed.
Okay, so
Now,
so basically that's it. That's the mission we are looking of the Black Sky Global 34 launch. This one I did not properly able to cover here, but it should be good and it should be fine. And yeah, maybe I'll add a little bit of text here because this will be a little bit of interesting. I'm going to show you guys soon what it will be. Okay, so oh sorry. If, in case you want to know why. Okay, because I'm going to show you another one here. Okay, this one I need to do a little bit of uh okay, okay, okay. So that's why I need to put the disclaimer there because otherwise uh okay, so because otherwise the will have a lot of copyright problems, so that's why. Okay, so I'm going to show you the next one here from NVS, if I remember correctly. We are going to see the test one here. Okay, so another one. Where's the NVS? Let me see. Not that kind of NVS. Another real NVS. Yeah, this one. Okay, because yeah, so we have to use this one. Sorry, we have to use this one. So as you can see, that's why I've already put the copyright logo there because we are using NVS Live here. Or yeah, I think that one should be good. Okay, so we're going to see this one is the hash 3 dash 30s for the flight 6 rollout where they are doing the captive firing test of the first stage booster around, if I remember, for the first 40 plus seconds into the into the testing here. So that's why I said we we have to put the disclaimer there because we're using directly straight out from the NVS live stream. So that's cool. Okay, so let me see. Let me see. We are not going to be that long. Okay, we are going to show you around. Okay, T minus 35 5 sec around, if I remember correctly, this one is around T minus 33 seconds, but it should be good. We're going to see here the um H330S. Yeah, 30S, yeah. What am I even talking about? I need I need to see. I need to show more there. H2. Okay. Okay, so it should be good. So we are going to watch here. This one is around T minus 33 seconds, not 35, because it fires a little bit earlier than indicated on the NVS. So we are going to watch, and this will be the last one before we end the stream. So yeah, let's go. Yeah. So you can see there. This one actually happens yesterday. Yeah. Yesterday on 15 March 2026. And then you can see it should be ignition. 2, 3, 1, ignition. No, a little bit late, huh? Okay, so it's actually 2 minutes late than usual, and then you should hear there engine. All right. All right. And then after that, okay, afterward, it cut off around 47 seconds into the ignition. So after that, the recaptive rocket engine test has already been completed. So you can see it's looking pretty beautiful. And then we shall see. Yeah, as you can see, this is zoom out from the NVS team here. You can see pretty nice. And you can see there, oh, what a vapor. Because how do I say, the entire rocket stages of the H3 rocket is actually powered by Hydrolox. Hydrolox propellant, which liquid oxygen as the oxidizer and liquid oxygen as the liquid hydrogen as the fuel. Yeah, as you can see, looks nice there, right? All right. So that's that. That's it. It's interesting to see it here. Okay. Nice. Oh, sorry. So yeah, thank you so much, everybody. Yeah, thank you so much, everybody, for joining in this live stream. And how do I say? Thank you so much. Even though you are watching, even though there's pretty much almost no one here watching, no one is in this room. But whatever, it's okay. Oh, sorry. It's okay. It's fine. I've got pretty used into doing this live with no one here, but it's okay. It's fine. It is what it is, and that's life for you. Okay, so thank you so much, everybody. And for tomorrow, around at least my local time here in Borneo, around 17 March 2026, around 10:37 7 a.m. or 27. Oh yeah, 10:37 a.m. Let me show you here. Okay, as you can see, this one I shall be able to stream tomorrow. Okay, unfortunately, I have time to do that just before my class, so I can do that, and also afterward, around how do I say, this is around around 8 hours later, around almost 8 hours later, there will be launch also of another Starlink, but from the Cape Canaveral. Okay, the first one would be the launch of the Starlink Group 17-24, launching from the Vandenberg Space Force Base. And then afterward, almost 8 hours later, it will be the launch of the Starlink Group 10-46 from the Cape Canaveral Space Force Station. So yeah, I'm going to be able to stream this too soon. Okay, to stream in one day. So it will be a bit bonus because afterward I'm not going to stream a bit more of the Starlink until probably next month. And also another reason why I need to get this one early is that because I would like to take a bit more time to rest, you know, so that's why. And also good news is that if I remember correctly from the schedule, from the time, there should be how do I say, there should be time where university will close, school will close and what's on because of Idil Adha, you know, the day after after the Ramadan fasting day for Muslim. Okay, at least from our time here, shall this how do I say, this Friday I shall be able to stream this one. But of course, yeah, fortunately it's a holiday, so I can afford to I can afford to hammer myself down with a little bit of unsleepiness. But yeah, it's okay. I will try to stream this one 8 days a week. Rocket Lab launches of the Electron/Curie rocket from Mahia Peninsula, and afterward 2 hours and 15 minutes later will be the launch of the onward and upward mission by ISAR Aerospace with the Spectrum rocket launching from the Andoya spaceport, Nordland, Norway. So we are going to see that soon too. And of course there's the rest of it and whatnot. And there's a new edition here, looks like it, Amazon Leo. Amazon Leo with the LA-05. Let me see, can I stream around this time? 3:30. Yes, certainly I can try to stream this one. So yeah, I can try to stream this one. So I will do that soon too. Okay. And the rest of it, we are not pretty sure if there's going to be it. Yeah. So yeah, thank you so much everybody. I shall see you guys soon tomorrow as well, tomorrow morning. So yeah, thank you so much, and I'm going to close this one with my typical speech here. So yeah, thank you so much everybody for watching. I'm Daniel Suguwa, your host today for the Progress MS-31 cargo resupply spacecraft undocking and also departure from the International Space Station, where it will re-enter back to Earth probably a few days later, or maybe a few hours, who knows. But yeah, that's it. The mission has already been concluded. And also I also show you the launch replay of the 10 days ago of the Electron rocket, and also recently, yesterday, yesterday is the H3-30S rocket engine firing test there. Because if I remember correctly, there is like some kind of how do I say, nozzle lining, if I remember correctly, or the combustion chamber cracking there. Yeah, but fortunately it was fixable, and now when it's firing back, I don't think they have any more problem, and it should be able to go and proceed for launches soon. So we are going to see the debut launches of the H3-30S by JAXA. That one is a little bit special in the H3 rocket family. That one is the only rocket so far, from what I know, that has 3 rocket engine on the first stage, instead of the typical 2 rocket engines configuration on typical flight, on the typical H3 rocket flight. And yeah, even then the 2 rocket engines configuration on the first stage on the H2 rocket, if I remember, H2 aka especially the H2 A and H2A rocket, usually it actually prominent with the only one rocket engines there. In comparison with the H2B, it has two rocket engines to actually accommodate with with more heavier heavier payload. In that case, it could be something to do with the it mostly something to do with the HTV HTV how do you say HTV cargo resupply spacecraft. This current generation is the HTV-X. That one is the newer version of it. It's sort of like the imagine like the Progress MS, but Japan version, something like that. Yeah. So you can get a little bit of insight what it does. So yeah, thank you so much, everybody, for watching, and I shall see you for tomorrow. Tomorrow launches of the Starlink Group 17-24. That one is in the morning. That one is in morning, and then followed by almost 8 hours later, the Starlink Group 10-46. So yeah, thank you so much, everybody, for watching, and take care. Goodbye, and have a nice day. And that's it. We've already done. That's it. Take a rest. Do whatever you want. Just, just do anything what you want to do. You want, I don't know, you want to go outside, you want to go sleep like me tonight, or you want to, well, check out my channel, maybe even you want to subscribe, like, share, I don't know, even go hype, comment. That's up to you. I'm not going to babysit you, that one. I'm not going to be that one annoying VTuber. I'm not going to be that. So do whatever you want. You have your own agency, right? You can make your own decision. So yeah, thank you, and see ya. Have a nice day. Goodbye. Take care.